What was this value, by the way? Wasn't it 1700 and something? What was it? 17, anybody write it down? 1,700 what? 36 and some amount of cents, because the bank would always care about cents. 75? Okay. So who knows what the bank would? 4375. I'm pretty sure the bank would round it down, even though it should round up. For the purposes of Math 12, if it's 4375, let's say 44, okay? Even though the bank probably would always round it down. I'm speaking, I don't know what the bank would always do, but you never know. How can you figure that out graphically? I do want you to use the technology here and check your work. I think you can gain a lot of insight by looking at something algebraically and looking at it graphically. We'll have to go back to we'll get rid of this one because this is not meaning anything. And we are only looking at 3, so probably we don't need to go up here. Let's go up to what we had before. Up to 12 is probably good enough. And we probably only had to go, oops, can't even remember now. Well, we know it's there, so let's go 5,000. That's good enough. Okay, there's our function. If you want to find, it's very slow growing. In the short term, it almost such a low interest rate. It almost looks like a straight line, right? You're not really gaining anything because of compound interest. How much do we have here? You know how to do it on the calculator. You can if you want a rough estimate, you could just do trace and go across here to 5. But unless you've set up your 3, unless you've set up your window nice, you're not going to be able to get exactly there. You're not going to get the right number. I want you to realize you can use this calculate menu above the trace. This first one gives you any value you want, even though it's not on an exact pixel. So there's that number. Okay, if you want to, I mean, you should probably write down how we got there, that calculate menu, to have at your disposal when you want to use the calculator, unless you're already an expert with that calculator. I want you to be able to check that. Second, calc value when x equals 3. Oops. Okay, so there's our number. Same thing, right? Being able to confirm things. It goes a long way. It goes a long way to be able to confirm something 2 different ways. This is 2 completely different ways of doing something. Really, it's the same. The calculator is doing what you're doing. It's just substituting the 3 in. But doing it 2 different ways and getting the same answer it really confirms, or it helps you have some confidence in your answer here. The other question is, how long is it going to take to turn into $3,000? Now we're going to do this. We're going to do this a couple different ways. You think about how you can do it algebraically and how you can do it graphically. Okay, oops. Think about how you can do it either way. I fight with this thing. Makes for a riveting video, doesn't it? Okay, we'll do it now. We'll look at the other way here. What we just found was we were taking an x value and finding the y value. Either way here, right? We were given x. We needed to find y. You didn't need any grade 12 math to do that algebraically. And you just needed some calculator skills you probably already had to do it graphically. That's not requiring anything to do with logarithms or grade 12 stuff. This is going to, though, because you think about what's involved here. Okay, so this says how long. Here we're solving for which variable in our model function here. We got 1500, 1.05 to the power of x. Which one are we solving for? What are we solving for? You're solving for x, right? Here we're given y. We need to find x. It's kind of the reverse. So you're gonna sub in here now 3,000. So you're making this substitution over here. Y becomes 3,000 equals 1,500 times 1.05 to the x. But we have learned all this nice stuff about logarithms, and you know how to solve this now. There's several ways you can solve this. I don't want you to necessarily just memorize one thing. Some people are troubled in solving this when there's this number in front. There's several ways you can deal with that. Most people, I'm hoping you're okay. Let's say that equation was there, but the number wasn't in front. It just said 3,000 equals 1.05 to the x. How would you solve that if it was just that? Or in other words, let's just call this a equals b to the x. How do you solve an equation like that? If the variable's in the exponent, what do we have to use? We have to use logarithms, right? If you take the log of both sides, log a equals log b to the x, you can move this right to the front here. You can make it bigger. Don't you guys have to go for GQ? Okay, to solve that then, you just isolate the x. X equals, you divide that. The difference is here we got this number in front. How do we deal with that number in front? What's one way you could deal with the number in front? Yeah, you could divide. One way is to divide by 1,500 first. Don't think that, okay, this is the only way I can deal with it. But that's one way. You can divide it because then you'd have 3,000 over 1,500. Or in other words, you'd have 2 equals 1.05 to the x. You don't need the brackets anymore if you get rid of that 1,500. Then it looks like what it looked like over there, right? Now you can solve it the same as it was over there. This, I'm hoping by the time you're done this unit, you could do this kind of in your sleep almost. X times log 1.05. So you get x is whatever log 2 divided by log 1.05 is. Might as well actually find the real number on the calculator here. Make sure you're putting brackets in the right place when you're doing this. Log 1.05. 14.21. What was it? Years? Okay, there's our amount of time. What would be another way you could solve this original equation here? If you started with this, what could you do? What else could you do? What if somebody, what if somebody did that? That would be a big mess. What if somebody started by taking the logarithm right away? Let's say they were awake on the day we said you take the logarithm of both sides, but they were not awake on any other day here. They said, oh, I know, you're supposed to take the logarithm of both sides. Does this mean they're 1,500 times 1.05 to the x? Would that work if you did that? You have, this side's easy. This side you have logarithm of something times something else here. Can I take this x and put it in front of that logarithm now, the way it is? No, why not? You could up above because this x applies to this entire thing here. Does this x apply to the entire thing? No, just the 1.05. You do have two things multiplied. You got log of 1,500 times log of 1.05 to the x, and you learned a rule for that. You learned a rule for log of two things multiplied. How can you deal with that? You're gonna get it if I say log of AB. What is that equal to? Yes. This means that you know it, but you don't know it to the level that I'd like you to know it to. You know it at either the knowledge level. Just memorizing this is knowing it at a kind of a knowledge level. Being able to apply it in a new situation like this is not an easy skill, but that's understanding that multiplication rule at a higher level. If you have two things multiplied, you could follow it through like this, 1,500 plus log of 1.05 to the x. I'm not suggesting that this is the simplest way, but don't panic and think that it doesn't work anymore. That would work, right? You could move this term over to the other side then. You could put the x in front. This would lead to the same answer. What you can't do is what a lot of people do. They do this. They say, oh, I have 3,000 equals 1,500 times 1.05 to the x. I might as well multiply that first, right, and get this, whatever number that is. You can't multiply that and say 1,500 times 1.05 is something. Okay? You can't multiply those two first because the x only applies to the 1.05. Make sure your answer makes sense when you get it here. Okay? Can you try and model this decay problem here? Think about what the rate that's involved is. Actually, and then I'll